CHS. We're going to do another lesson today. We're actually going to talk about something brand new. And what we're going to do, since it's brand new, is we always start with the basics. So we're going to talk about something called a logarithm today. So up to this point in this chapter, we've talked about exponential equations and exponential functions and all different things we can do with that. Next, we're going to transition into kind of the opposite of exponentials, which we really haven't talked about in the past, and that's called a logarithm. What a logarithm does is it helps us find hard exponents, basically. So with our last lesson, we were able to take, if it was a base of 3 and a base of 9, we could take the 9 and adjust it down, or we could adjust both bases down. But what happens when we get numbers that aren't related and we need to solve those for those exponents? That's where logarithms come in. So whenever you solve a logarithm, what you're finding is a hard exponent, basically. An exponent that's not equal, so that you can figure out, okay, 4 to what exponent equals 10, okay? That's not going to be a very easy exponent to find, but with the help of a logarithm, which we're going to talk about today, eventually we'll be able to find those hard exponents. So a logarithm is defined as an inverse of an exponential function. So like I said, it's the opposite. So everything in math has an opposite all the way back to addition. We had addition and then subtraction was its opposite. We had multiplication and division was its opposite. So everything in math has an inverse for the most part. So whenever we're finding an exponential, a hard exponent, what we do is we switch to a logarithm, because a logarithm is an inverse of an exponent. Okay. And so again, I have that sentence there. A log is an exponent, just to remind you again, whenever you're finding a log, whenever you're evaluating a log, solving with a log, you're finding those hard exponents that are not easy to find. So let's look at the definition. To explain a little bit, I like to use the cursive L whenever I write logarithm, because sometimes when you write the L, it kind of looks like a 1 or an I. So I always use the cursive L. So when I typed it out, I decided to find a cursive L to write out, to type it out, so it looks like what I typically write. So here we have, the way we say that is log, and then next to log, typically there's a little number here, that's the base. So it's log base b, and then this is what we're taking the log of. So of y, so log base b of y equals x. So that's how you say it on the logarithm end. And so then what we can do is you take all the numbers that are in and around log, which there are 3 spots. There's a base, there's what you're taking the log of, and you have what it equals. We can translate that into its exponential counterpart. So the base of the log is the same thing as the base of the exponential counterpart. X is the exponent, which is what the log equals, because that's what when you solve log out, what you're finding is exponents. So it's b to the x, and then it equals what was in with y, or what was in with log and y. So it's b to the x equals y. So if you kind of notice, it's the same 3 letters, they just kind of translate from one to the other. And a lot of times I call this the walk-around method, because if you look, you start with the base, because the base of the log is the same thing as the base of the exponent. It kind of goes around the y over to the x, that becomes its exponent, and then it equals what was back with y. So I'll talk more about that as we go along. Now there is a couple of restrictions, just because there is, with exponentials, there's a couple of restrictions anyway. So these 2 numbers, the base and what you're taking the log of have to be positive. In fact, if you try to take a log of a negative number, it doesn't work. It gives you an error. And then also you can't have a base of 0, because 0 raised to exponents is just going to be 0, and sometimes it's undefined, and so it doesn't usually work quite right. Okay, the other base you're really not going to see is 1, because 1 raised to the exponent is also 1. It's not necessarily a restriction, but again, you're not going to see that. So the base can't equal 0. So like I said, what we're going to do with this today is just kind of get used to this idea that we can go back and forth from logarithmic form to exponential form. So we're going to go back and forth, so we're going to know all of the things, because eventually in one of these 3 spots, we're not going to know something, so we'll have to solve for it. Same thing here, there's three spots in the exponential, same idea. And then also talk about how you can evaluate it using your calculator. So we're going to do those 2 things today. You're either going to be given something that starts off in logarithmic form or starts off in exponential form. It's pretty easy to tell the difference between the two. If it's in logarithmic form, your initial equation or expression is going to have a log in it. If it's an exponential form, it doesn't have a log, it has something with an exponent. So that's a quick way to tell whether it's exponential or logarithmic form. So here's our first logarithmic equation. So notice we have 3 parts, and we know all 3. We have the base of the log, it's a 3. We have what we're taking the log of, it's 9, and we have what it equals. So again, the way we'd say this is log base 3 of 9 equals 2. So that's that information in logarithmic form. So like I said, we know all the parts, so we're not really solving for anything. What we're doing is just rewriting it. So we're going to use that definition to rewrite this from logarithmic form into its exponential counterpart. So this is the method I like to call walk-around method. Like I said, that's not the official term for it, but here's how it all works. So what we're going to do when we rewrite is the log is going to go away because it's we're going to take it from logarithmic form to exponential form. So where we start is this base, the 3. So that little 3 is going to become a big 3 for exponential. So I'm going to start with the big 3. Again, log is going to go away. So we start with a little base. Then we walk around the equal sign to the 2. Because the 2 is the number we're going to use next. What 2 is, it's the exponent on this big number that I wrote. So it's going to be 3 to the 2nd power. So I'm going to write that as an exponent. And then it equals, if we walk back to this number here, it equals 9. So we started with logarithmic form, and we wrote it into exponential form, which if you notice, we've known for a long time that 3 to the 2nd power equals 9. So this thing is something we've seen before. What we started with was that same information in logarithmic form. So if we use that handy-dandy walk-around method, we can always translate something from logarithmic form into exponential form. Like I said, this is the form that we've seen in the past, because we've known for a long time that 3 squared equals 9. So, like I said, eventually what's going to happen is you're not going to know something in here. So like, say it was a 3 here, we had an x here, and it equaled 10, okay? Eventually what we'll do is figure out, okay, we can translate it so that we can figure out the x that's inside the logarithm. But like I said, for our first lesson here with logarithms, we're just getting used to the fact that we can go back and forth between exponential form and logarithmic form. Okay, let's do another one. So here we have log base 8 of 1 equals 0. So we're going to take that, we're going to translate that into its exponential form. So again, log is going to go away. We're going to start with the little base on log. It's going to become our big base. Walk around to the 0. 0 is our exponent. And then walk back to the 1, because that's what it equals. And we had a rule a long time ago, anything raised to the 0 power is 1, so this is also true. So again, as long as you follow that correct order in the walk around, you should be able to translate it into whatever exponential statement you want. So let's do one more. Sometimes you'll see some different ones. So here we have log base 5 of 1/25 equals 2. So again, no matter what numbers you have in and around your log, to rewrite it into exponential form, you always start with the little base. It becomes the big base. We walk around to the -2, that's your exponent, and then it equals 1/25. And that's just to give you a quick reminder about exponents. Whenever you have something raised to an negative exponent, it does not turn it negative. So that's why whenever you take a log of a negative, it doesn't work. What it does is it does the reciprocal. So that's why 5 to the -2 is 1/25, because you flip it and then 5 squared is 25. So we just give you a quick reminder about exponent stuff. It's been a while since you've talked about that. But that's how you take something from log form into exponential form. And again, the way you tell the difference between the two, we start with log form. We know it's log form because it has a log in it. and we translate it into exponential form, which looks nothing like it, but it doesn't have log anymore, but it does have an exponent. So this was logarithmic form, this is exponential form. So we're going to take, and we're going to do it in reverse. So we're going to start with an exponential form and rewrite it into its logarithmic counterpart. Kind of the big thing to get used to with this stuff is that exponentials and logarithmics, while they're inverses of each other, they don't really look anything alike. So you're going to start with something that has a log and rewrite it into something that doesn't. And then here, we're going to do the opposite. We're going to start with something that does not have log, and we're going to rewrite it into something that does. So this is our exponential form. Again, you can tell that because there is no log to start with. So we're going to take it and translate it into a logarithm. So the first thing I'm going to do is write my log, and it's going to reverse completely. So we actually still start with the base. So before the base was the little number next to g. Here the base is the number that has the exponent. So where that goes is it's the little number next to g. That's where it translated to in the reverse process. Then you're going to do still the walk around. The next number we're going to use is 125. Now this one, it's not really an exponent here. It's just leave a little space. And then write 125 as normal. So again, this number is like a little subscript to log. So it's a little number next to g. Leave just a little bit of space and then write 125 normally. And then we walk back to that exponent, because that's what logarithms equal. Logarithms equal exponents. So 5 to the third power is 125. That's true. And now we've rewritten it into its exponential counterpart. Or sorry, logarithmic counterpart. So we have log base 5 of 125 equals 3. I'll do one more quick example, and then we'll talk about evaluation. So there's a couple of different things that I like to show you. Here's one. You can actually have fraction exponents. Whenever you have fraction exponents, usually some bigger number raised to fraction exponent makes it smaller. That should make sense. So again, we're going to start with our log. So whatever the base is here, so even though 256 is kind of a bigger number, it's the base on the log, so it's going to go to the little number next to the g. Then you walk around to the 4. Again, just leave a little space and write 4 normally, and then it equals that exponent. So we can have all different kinds of bases, exponents, all of that. So whenever you rewrite it into a log, like this number doesn't have to be the smallest. This number can be bigger than that number. This number can be a fraction. You can have some negatives in there a little bit. The only things that won't be negative are the numbers. The two numbers that are with log should not be negative in order for this to work. But yeah, those are doing the opposite direction. Started as an exponential, rewrote it into a log. Give me a couple seconds to look at that. So the next thing I'm going to show you is how to evaluate these. All calculators have a log key on there somewhere. A lot of times it's with my blue calculator, it's in this first row buttons. It's actually right underneath the second key. The log that's programmed into all calculators is a specific log. So when we're trying to find other logs, there's a couple of things we have to do in order to make it work in our calculator. So now we're going to talk about how to evaluate a log. Okay. So I talked about at the first slide that every log, whenever you're solving it out, it's finding those hard exponents. So whenever you're evaluating logs, you are finding those. So all calculators have a log programmed in. On this calculator, log is right here under the second feature, but all calculators have some type of log button. Now, what makes it a little bit tricky is that the logs that are programmed into all kinds of calculators, I'm actually going to show you two calculators, this one and then my board calculator, because they're slightly different how we type those in. All the logs programmed into any calculator is base 10. Excuse me. And that's called common log. So it's the one that's used most often in the real world. A big thing is pH and chemistry. Some forms of that use logarithms. So it's base 10. So actually when you see a log and there's no little number here, it's actually unassumed little 10, okay? And I talked about this a little bit before. Log doesn't have base 1 because 1 is pretty boring as far as exponents. So most common log is base 10, and so a lot of times you actually don't see that typed. So the way this one would work out is what it's asking us to do is find the exponent we put on 10 that equals 6, which is not going to be a nice number because we know 10 to the first power is 10, 10 to the second power is 100. So to get an exponent to put on 10 to equal 6 is not going to be very nice. But that's the nice thing that the calculator is programmed to do. So on my blue calculator, I'll show you. You can type log, just hit the log key first, hit 6, and then hit equals, and then that'll tell you what the log should equal. And so it's not a very nice number. We typically round to 3 decimal places when we round for exponentials. So we're going to do 0.778. So that's the exponent you put on 10 to equal 6. So that's one way to work with the calculator. Some calculators you have to just do it backwards. So here I have to type my 6 first and then hit log. But again, I get the same answer. We're out of 3 decimal places, so I did 0.778. So there's how we can do it with just common log. So if whenever we have base 10 or just regular log, whenever you see that written, you can just type it in as is. So now what happens if instead of a 10 here, we have a 4, we have a 3 or something like that, that's where we have to do something called the change of base. Now sometimes a logarithm might give you can actually think about it a little bit, because remember how we got this number, or how the calculator gave us this number, is the exponent you put on the base that equals the other number that's with log. So it's 10, because if you do the walk around, 10 to that equals 6. So it's finding the exponent you put on the base that equals that other number. So some of them you might be able to think out a little bit, but most of the time we're looking for harder exponents. So we have to do the change of base. We actually end up having to hit log twice on our calculator. So here's how that works. With this one, order does really matter. So really make sure you're careful with how you type it in. So if we're looking for a different base other than 10, so we have log b of y. So what we do is first you do log of the y, so log of the bigger number, the outside number, however you want to say it, and then you divide it by log of the base. So like I said, you end up having to type log twice. So you log of the outside number divided by log of the base. So it doesn't go in order, so it actually goes in reverse. So do log of y divided by log of b in order to get that done. So for example, if I have log of 4 and then 80 here, what it's asking me to do is find the exponent on 4 that equals 80. Okay, that's not going to be a nice one. The way we can do this, in your calculator, you're going to do log of 80 first, and then divide it by log of 4. Now some calculators, like with my blue calculator, when you type log, it automatically puts a parenthesis there. So if you want to make sure you evaluate this correctly, make sure you close that parenthesis before you hit divide, otherwise it reads it incorrectly. And then same thing here, I usually just go ahead and close it. Some calculators require the parenthesis at the end, some don't. So I just go ahead and do it. So I'll show you that. So we're going to do log of 80, close the parenthesis, and then divide it by log of 4. And so that's the exponent you'd put on 4 to equal 80. So it's 3.161. So that's the exponent you'd put on 4 that equals 80. So it wasn't going to be a nice answer. So again, if you do the walk around, it'd be 4 to this equals 80. So it's always the exponent you put on the base that equals the other number. And so that would be a little over 4. And actually, if you try that 4 to this exponent, it should get you pretty close to 80. We did have to round a little bit, so it might not be perfect. So that's how you do on the blue calculators. On the calculators like I have up here, this one imitates the iPhones a lot. So what I have to do is I kind of have to type it a little backwards. So I do 80 first, and then hit my log. And so the number showing is a log of 80. So now I hit my divide, and then I have to type the 4 next. Now this is not my answer. This is actually log of 4. So to get my final answer, you just have to click equals, and that's where I get my 3.61. So again, if you have a calculator like my blue one, you can just type it in order. Just make sure you close that parenthesis. If you have to use your phone calculator, or if you have a calculator, you have to type stuff backwards. Start with the number, hit log, divide, then the next number, log, equals. Don't forget to hit equals at the end in order to get that done. Okay. Let's look at 2 more. So here, what it's asking us to do is find the exponent we put on 5 that would equal 20, okay? So I know it's not going to be, it's going to be close to 2, because 5 squared is 2, or 5 squared is 25. So I know this is going to be close to 2, but we're going to find the exponent we put on 5 to get to 20. So the way I would type that in, do log of 20 divided by log of 5. I'm just going to show it on the board calculator. So I'm going to do 20, log of 20 divided by log of 5. And then equals. So we got 1.861. So again, I had a feeling it was going to be close to 2 because 5 squared is 25. So the exponent you put on 5 that equals 20 is 1.861. And so let's look at this last one when we've done. So this is asking for the exponent you put on 4 that equals 64. Now if you're good with exponents, that is actually going to work out as a nice whole number. So it's 4 to the 3rd power is 64. So if you're good with exponents, you can actually think about this a little bit. 4 to the 3rd power has to equal 64. So sometimes you won't necessarily need to use your calculator, but if you're not quite good with exponents, you can still type it the same way. Do log of 64 divided by log of 4. And I'll do this on the blue calculator to show you. So I do log of 64 divided by log of 4, and there's my 3. So again, some of them won't require a calculator necessarily, because if you're good at thinking with exponents, then sometimes you can think them out, like with this one. So I knew that 4 to the 3rd power is 64, so I did this one without using my calculator. But again, if you're not quite sure, you can always use the change of base. And for the most part, what we'll be looking for are those harder exponents. So the exponent you put on 5 to get to 20, the exponent you put on 4 to get to 80. So most time, questions like that, calculator is required. But sometimes, you just think about it, you might be able to do it without. I'll give you a second to look at that. So we'll probably spend a couple days on this, just to make sure we're good to go. Again, we're starting off with some basics, because eventually what will happen is we'll end up having to use this to help us solve for X or different things like that. So I hope all this made sense. Please let me know if you have any questions for email purposes, or again, I do a Google Hangout that I post on Classroom every Monday and Wednesday, so just let me know. See ya.